Let's find the second moment of area of this section about the horizontal axis. So what we'll do first is evaluate the polar moment of inertia, which is the integral of r squared over the area, and then using the following relationship between the polar moment of inertia and Ixx and Iyy, we can obtain Ixx. So here we'll take an infinitely thin circular ring which has a width dr, and the distance from the origin to this ring is r. So therefore the differential area of that ring is 2 pi r, being the circumference, and multiplied by the thickness. So effectively we're rolling it out as a rectangle. And now we can substitute this in the expression for the polar moment of inertia, where we're integrating from r equals 0 to the radius of the circle r. So we have r squared by dA, which is 2 pi r dr. So we can take 2 pi outside the integral, and then integrating r cubed gives r to the 4 on 4, and that's evaluated from 0 to r. So therefore we have 2 pi multiplied by r to the 4 on 4. So therefore the polar moment of inertia is equal to pi r to the 4 on 2. And recognizing that the circle is symmetric, Ixx is equal to Iyy. So we have Izz is 2Ixx, and the polar moment of inertia is pi r to the 4 on 2. And solving this equation gives a second moment of area about the x-axis as pi r to the 4 on 4, which is the same result we got in a previous video using the more difficult method. Please subscribe, like and comment to help me reach more students.